Hi, how are you? In this video, we are going to solve the session 2018. So in this, we have the function f defined over the interval 0 plus infinity by fx equals x minus 1 plus ln x over x. We have solved before a similar exercise, but here instead of minus, we have plus. And C is its representative curve in an orthonormal system. Pay attention for the unit 2 centimeter. We use it here in order to calculate the area. So the unit 2 centimeter, and upon drawing, whenever you are going to draw, each 2 centimeter will be 1 unit. And we have the line d y equal x. So we have the function f defined over 0 plus infinity. And we have the line d of equation y equal x. Study, according to the values of x, the relative positions of C and D. We are going to study the positions of C and D. So, to study the position between C and D, you have to study the sign of fx minus yd. Sign of fx minus yd. If fx minus yd negative, C is below D. If fx minus yd is positive, C is above D. And if it is 0, then C cuts D. fx minus yd will be equal fx minus yd equal minus 1 plus ln x over x. So pay attention. This minus doesn't mean that this expression is negative. So we have to solve it equal to 0. So we solve minus 1 plus ln x over x equals 0. It means that 1 plus ln x we multiply by minus over x equal to 0. So the numerator is 0. 1 plus ln x equal to 0. It means that ln x equals minus 1. If we need to remove ln, we add e to the next side. So x equal e to the minus 1 equals 1 over e. We make a sign table. Here I put x. Here we put fx minus yd. And here we put position. We have to put the domain, which is 0 plus infinity. And we put the value of x, which is 1 over e. Here we put 0. For example, if I need to know the sign between 1 over e and plus infinity, if I take x equal 1, if we replace x by 1, the x equal 1, بيصير عندنا the expression fx minus yd will be minus 1 plus ln 1 over 1, which is equal to minus 1. هذا ln 1, which is minus 1. In here it is negative, here it is positive. And we study the position fx minus yd positive, yani c is above d. So we go here. So to study the position, fx minus yd will be x minus 1 plus ln x over x. It is minus 1 plus ln x over x equal to 0. We solve it equal to 0 because we don't know its sign. 1 plus ln x equal to 0, and x equals e to the minus 1, 1 over e. As we said before, here positive means c is above d. Negative, c is below d. And at 0, we say D cut C at 1 over E. And since the line D is y equal x, then we get 1 over E, 1 over E. So we replace the value of 1 over E either in the equation of the line or in the function. But here it is easier to replace 1 over E in the line, which is y equal x. So we get y equal 1 over E. We go to the second part. Determine limit fx as x tends to plus infinity, and show that the line D is an asymptote to C. So we have two steps. Limit fx as x tends to plus infinity. How to calculate the limit as x tends to plus infinity? Limit as x tends to plus infinity of x minus 1 plus ln x over x equals infinity minus ln infinity is infinity, so minus infinity over infinity. This infinity over infinity gives indeterminate form. So we apply Hospital's rule only to the fraction part. This one remains x. So we say limit as x tends to plus infinity. But we have to mention that we use Hospital's rule. By using Hospital's rule, this one will be x minus derivative of ln x is 1 over x over 1. By replacing x by infinity, we get plus infinity minus 1 over plus infinity, which is equal plus infinity. So limit as x tends to plus infinity of fx equals plus infinity. Now we are going to verify that the line D y equal x is an asymptote. So you have to determine the limit as x tends to plus infinity of fx minus yd. Fx minus yd, we remains minus 1 plus ln x over x. So we get infinity over infinity. Since ln infinity is infinity over infinity, so we get infinity over infinity. We use Hospital's rule. Limit as x tends to plus infinity, we say derivative of ln x is 1 over x with this minus. So minus 1 over plus infinity is 0. Therefore, the line D of equation y equal x is an oblique asymptote to C at plus infinity. Determine limit fx as x tends to 0. X greater than 0 means here x tends to 0 plus. So x tends to 0, x greater than 0, x tends to 0 plus. We replace x by 0. Ln 0 is minus infinity over 0 is minus infinity times this minus is plus infinity, and deduce an asymptote. Then we can say that x equals 0 is a vertical asymptote. So limit as x tends to 0 plus of fx. We replace each x by 0, 0 minus 1 plus ln 0 plus over 0 plus equals 0 minus ln 0 is minus infinity. Minus infinity over 0 plus is minus infinity times minus, we get plus infinity. Then we say that the line x equals 0 is a vertical asymptote. Now we are going to, we have a certain graph here. We are going to take some information from this graph. In the adjacent figure, G is the representative curve of f prime. So this is the curve of f prime, not of f, the curve of f prime, the derivative of f. F prime is the derivative of f. G admits a maximum هذا على radical E here we have G is a maximum. G admits a maximum at x equal E for x equal E radical E, that we are going to use this one later in the exercise. G intersects the x-axis, G intersects the x-axis at a point of abscissa 0.6. So once again, this is the representative curve of f prime, the derivative of f, and you are given some information. These informations here are important that are going to be used in this exercise. You need maximum at radical E, and G intersects the x-axis at the point of abscissa 0.6. Set up the table of variations. How to set up the table of variations? To set up the table of variations, you have to study the sign of f prime. We have to know the sign of f prime. So table of variations is determined by the sign of f prime. From this curve, if you notice that f prime is 0 at 0.6, for x equals 0.6, f prime is 0. Between 0 and 0.6 in this interval, we notice that the curve of f prime or g is below the x-axis, means f prime x is negative. And if x greater than 0.6 here, g is above the x-axis, g is above the x-axis, g is the representative curve of f prime, and f prime is positive. So f prime is 0 at x equals 0.6. Between 0 and 0.6, f prime is negative. Greater than 0.6, f prime is positive. So we do the following. So from the curve g of the function f prime x equal to 0 for x equals 0.6 graphically. F prime x negative, g is below the x-axis, x belongs to 0, 0.6. And f prime x is positive if x belongs to 0.6 plus infinity. So table of variations, x, f prime, this is not fw prime, f prime x, fx, we put 0, 0.6, 0.6 from the above, plus infinity. We have seen that at 0.6, f prime is 0. Between 0 and 0.6, f prime negative, here positive. Negative, the function is decreasing. Positive, f prime is positive, f is increasing. At 0, we get plus infinity. We put plus infinity here. Add a plus infinity home. At plus infinity, f of 0.6, f of 0.6, by using the calculator, we get minus 0.21. At 0, we have a vertical asymptote. You can add this. It is optional. And at plus infinity, we have oblique asymptote. At 0, the curve is coming near the vertical asymptote. At plus infinity, the curve will be near the oblique asymptote y equals x. Show that the equation fx equals 0 admits exactly two roots. First, we are going to prove that it admits two roots, but then one of them is equal to 1. We are going to prove fx equal to 0 admits two roots. If someone try like that, if we try x minus 1 plus ln x over x equals 0. We take the LCM, which is x. We get x squared minus 1 minus ln x equal to 0. it means that x squared minus 1 minus ln x equals 0. This equation cannot be solved. It is difficult to solve this equation. We have a polynomial part and a log part. So we are not going to solve it by this method. Okay, we are going to search for another method in order to solve fx equal to 0. Now, if we go back to the table of variations, we say that if you notice between 0 and 0.6 in the interval 0.06, f is decreasing from plus infinity, from a positive value to a negative value, minus 0.21. So f is decreasing, f is continuous and decreasing from plus infinity to minus 0.21. Then the curve C, since we are above the x-axis, we go down to the below the x-axis. So the curve will cut the x-axis at one point. So fx equals 0 has one root between 0 and 0.6. Also in the interval 0.6 plus infinity here, f is continuous and strictly increasing from a negative value to a positive value, decreasing from a negative to a positive. Then fx equal to 0. Fx equals 0 admits one root. So fx equals 0 admits two roots. Yani if we have the curve like that, if the curve is decreasing from a positive value of y to a negative value, so we cut the x-axis once, this is fx equal to 0. And if we are decreasing, if we are increasing from a negative value to a positive value here, also here is fx equal to 0, one root. Why the fx equal to 0? How we have another root. So fx equals 0 admits two roots. So here, fx, we are going to verify fx equal to 0 has two roots. As I said before, f is decreasing from plus infinity, which is positive, to minus 0.21, which is negative. Then c cuts the x-axis at one point. So fx equals 0 has one solution or one root. F also is increasing from minus 0.21 till plus infinity. Then C cuts the x-axis at one point. So in all, fx equals 0 admits two roots. To verify that one is a root, one of them is equal to 1, you calculate f of 1 and it will be 0. F of 1, we replace x by 1. 1 minus 1 plus ln 1 over 1. This ln 1 is 0, so we get 0. Then, so 1 is a root of fx. 1 is a root of fx. Denote by alpha a second root of the equation fx equal to 0. Verify that alpha is between 0.4 and 0.5. This is simple. We calculate f of 0.4 and we calculate f of 0.5. One of them will be negative and the other is positive. So we find f of 0.4 is 0.19, which is positive. F of 0.5, we get minus 0.011, which is negative. So alpha is between 0.4 and 0.5. Show that C admits a point of inflection whose coordinates are to be determined. C admits a point of inflection whose coordinates are to be determined. How to determine the point of inflection? The point of inflection is the point where the second derivative is 0 and the second derivative changes sign. هلا نحن هيدا since this curve is the curve of f prime, I can make the table of variations of f prime in that way. This curve is the table of variations of f prime. F prime is increasing then decreasing. So I can do the following. هيدا domain of f prime x, here should be plus infinity أكيد. f double prime و f prime, f double prime و f prime. Positive here, negative. Positive since f prime is increasing in this interval, f prime is increasing, and negative because f prime is decreasing in the other interval. So at x equal f double prime x equal to 0 for x equal radical e, and f double prime changes sign from positive to negative, f double prime 0 at radical e and changes sign. So we have a point of inflection. To find the ordinate, I calculate f of radical e. You can use your calculator. I get radical e. We replace x by radical e. 1 plus radical e over radical e. Radical e, you can use your calculator, or radical e, ln e to the half, half ln e, which is half. You get the value of y, then the point of inflection is radical e 2e minus 3 over 2 radical 3. 2 radical e is the point of inflection. So the point of inflection is the point where the second derivative 0 and it changes its sign. As I told you انه في هول الهنتس بنستخدمهم هون وقت قلنا هو هون G admits a maximum for x equal radical e. G admits a maximum. So we use it here now for calculation the point of inflection. Part E. Determine the coordinates of A on C where T is parallel to D, where the tangent is parallel to D. Tangent is parallel to D. So two lines are parallel if they have the same slope. Tangent at A is parallel to D. In slope at tangent equals slope at D. D is of equation y equal x. Then slope at tangent equal 1. So I can put f prime of x, slope of the tangent is f prime x equal 1. From the table أو from the graph إذا بتلاحظوا هون هيدا 1. f prime is 1. f prime is 1. هيدا f prime is 1 here for x equal 1. So f prime of 1, f prime of equal to 1 for x equal to 1. So from the graph x equal 1, f prime of xa equal 1. هذا f prime equal 1 here هون. x is equal to 1. So x equal 1. To find the ordinate, since the point A is on C, it is on C, we calculate f of 1, and f of 1, we get it 1. f of 1 is 0. f of 1 here 1 minus 1 plus ln 1 over 1. So A is 1, 0. Draw D, T, and C. Draw D, T, and C. Line D is y equal x. This is the oblique asymptote, y equal x. Tangent, I locate A. هون أخذت أنا كل 2 سنتيمتر 1 unit. إذا بتلاحظوا هون كل 2 سنتيمتر 1 unit. ال A هي 1, 0 here. And I draw a line parallel to D because the tangent at A is parallel to D. This is the tangent. I put the minimum here, the minimum point, we have the minimum is 0.6 minus 0.21. 0.6 minus 0.21 is here in this place. So according to the table of variations, وإذا بدنا فينا ال point of intersection of the curve at 1 over e, 1 over e, the point of intersection of the curve and the oblique asymptote is here. 1 over e is 0.36, 0.36 is here. So the curve is decreasing to the minimum. It makes a tangent at A, then it goes near the oblique asymptote. Decreasing, you follow the table of variation, then we get this one. Now, calculate in centimeter square the area A alpha of the region bounded by C and D and the two lines of equation x equal alpha and x equal 1. So the area is equal to the integral from alpha to 1 yd minus fx, area equal integral from alpha to 1 yd minus fx dx units square of area. So it is equal fx minus yd is 1 plus ln x over x. By changing the variable, units square أكيد. By changing the variable by the method of substitution, always, whenever we have ln x in the numerator and x in the denominator, we take the method of changing of the variable. U equal 1 plus ln x. du is equal 1 over x dx, dx equal x du. You change the bounds for x equal 1, 1 plus ln 1 تعطينا u is 1. For x equal alpha, u equal 1 plus ln alpha. So the area is equal 1 plus ln alpha to 1. The bounds becomes 1 plus ln x, we call it u over x times x du. X and x are simplified. We get u squared over 2 between 1 plus ln alpha square and 1. So it is equal. So we replace first u by 1. We get 1 over 2. Second time we replace u by 1 plus ln alpha over 2 squared times unit square. Unit is 2 centimeters square. Pay attention that the unit is 2 centimeter. 2 square is 4. 4 is multiplied by this value. We get 4 divided by 4 times half. We get 2 into 1 minus 1 plus ln alpha square. We expand, we get minus 2 ln alpha into ln alpha plus 2. So we get A alpha. This is the first part. Part B, prove that A of alpha equals 2 minus 2 alpha power 4. Prove that A alpha equal 2 minus 2 alpha power 4. احنا ليش طلعت معنا هون؟ ال A alpha طلعت معنا فيها لن. بس هو شو بده الجواب؟ بده الجواب ما يكون في لن. بده الجواب ما يكون في لن. شو هو الجواب؟ كيف ما نجيب؟ بدنا نشيل اللن من هون ونرجع نشوف الالفا. منين الاوريجين اوف الفا؟ الالفا هي is a root of the equation fx equal to 0. So I say, but f of alpha equal to 0. يعني alpha minus 1 plus ln alpha equal to 0. So alpha squared equal 1 plus ln alpha, and ln alpha equal alpha squared minus 1. We replace ln alpha by its value here in this equation. Let's say minus 2 into alpha squared minus 1 into alpha squared, هذه ln alpha, تصير alpha squared minus 1 plus 2. بتصير minus 2 alpha squared minus 1 into alpha squared plus 1 تعطينا alpha power 4 minus 1. نفوت, we multiply by minus 2, we get 2 minus 2 alpha to the power 4 centimeter square. Okay, this is all about this important exercise. Please write the notes, and if you have questions, please ask me next time.